Hello.
Okay, so not getting camera.
I wish they Yeah.
So, as often as I can get out of the tyrannical yoke of Fran, it's a nice to be able to breathe free. She's not going to even with you on this daily basis.
It's so weird. I heard.
It says we're broadcasting, but I'm not seeing the camera. There's a lens camera. Still nothing.
Maybe just saying.
When in doubt, it's a lens camera. Yeah, but it's not even trying to go to the camera. Let's see.
My VGA adapter. Generation of human. My dad was a commercial technologist.
Bag of tricks.
What? That was so smooth.
Okay, I don't know. How was the trip down?
It was fine. There was a little bit of slowdown.
That infamous stretch, I have some pictures I'd like to show you.
Yeah, unless they're widening it to 3 lanes, 6 lanes.
That's what the construction is about. But because of it, the trip to Denver points north is just astronomy.
Yeah, we were trying to come a side route close to the mountains, but we ended up like on I-25.
Going down Palmer Lake and like that.
Yeah. Maybe we'll go back that way.
All right,
So I'm wondering if I can borrow the VGA connection just to test this out. When do you think I'll be? Yes. You've got like side of his interest.
Right there.
So yeah, let's make this
Not today.
right now.
That distance causes such a problem. At least the so I was thinking about given the spectacular success of what is it then for you? What is the price of company today? Funding your laboratory. This is our springs, so those are questions. We don't insist that every speaker kneels.
But in his case, it's got a function.
Remember Bruce? I don't have a backup anymore. Yeah, she was talking about laughing and pointing. I don't remember why.
I usually get the slightly different reaction. It's all right.
Oh, 20? Really? I thought you were ready to go. Firemen and kill.
You know what? Probably I'd probably talk to Maya. Yeah, you could probably keep one of them. Two of them, and then you know what's gonna happen if someone.
Okay, all right.
Okay, let's test out your,
Some of them have, yeah, you can get mine.
well, okay, let me test, we'll try this. Setting it up. Yeah, that's the extent of the reach.
All right.
Well, no, there's a little bit more. Okay, let's see. That's working.
Now we'll see if
That's him. I just changed battery. I don't know.
Is it mirroring into here? No, that's my file.
Yeah, I don't know if this is really working well. This is,
It's the exact same thing.
where's your clicker? Oh, it's in your hand. Okay, try it.
It's not on
It's working a lot better. I mean, you're not seeing it because he's got, you can see how it's changing nicely. So we'll just use yours.
so. It looks like I'm good to go, except we don't have this.
Yeah, I don't know. And the sound coming through, you know what I do have is, I've got speakers. I've got speakers that can go in.
Okay, that wouldn't hurt if I have just a standard microphone jack.
Let me go get them.
But if it's co-opting sound, I expect
I don't think it did. Well, let me just try.
They bought the little company. They bought, yeah, they bought it.
the question is,
Yeah, I'm not getting sound. Oh yeah, I am getting sound. Okay.
just self.
It'll be a better minute. There's also, does this pick up? Okay, but so that okay, but that's not being broadcasted. It should, yeah. I just have to get
Unless you've already got one. I don't know how you operate if you want the freedom of doing this.
Yeah, it's good if I can. Yeah, that's just beautiful. Yeah, it's amazing how well this thing works. Yeah, anyway, it makes it good that way, except when they're not. Just to be on the safe side. It is, yes. Ah,
Collectible love.
I will look forward to it.
I don't know, I want to get down there Saturday. You can take it and give it. Give me soul, all my daughters, or give it to him. You already had them.
Well, should be playing sound now. The logo on it. We're also doing a picture.
Thinks it's talking to them.
All right, so it's working.
We'll have to adjust the volume.
You need to crank it all the way.
Yeah, it's cranked up on
Good. All right. So do you need this computer back for the beginning, or are we good to go?
That I don't know.
Oh, I was just going to ask if we had a long enough cord, maybe that can be moved over there.
If you need this presentation out before John speaks.
I mean, it's okay. I can just input.
I don't think so, do we? All I'm going to be doing is doing like general introductions and whatnot. I don't think we've met personally. Nice to meet you, John. Matt Russell. Thanks for coming down.
So-
I met your wife already, then. I saw actually you were. Was it last year? No, 2 years ago. Starts here. Yes. Yeah.
We've done it, I've done it twice.
Yeah. Yeah.
Good time.
I have it printed out. I'll read it.
If you want to, I mean, it's easy to just unplug and plug that back in.
I don't think so. So we are actually live right now.
Oh, we are.
And yeah, so we'll just we'll stay live on this one. John will run his presentation off that one, and everything's good.
So when we're approaching observer reports, if we can switch back.
John will be done. John will be done. Taking a break.
Observer reports are going to start before the break.
Either way, all I have to do is take his video cable and plug it in over here. We're good to go.
Yes, I can just give you that back.
Right. This right there, that cable.
That and that.
Yes, would come over to here. That's all.
VGA is going to go there. And that's going to go.
Hi, John. I'm Scott.
So Brian is reminding me, he goes, how many of the red light headlamps? My first question is going to be, I almost thought about that.
Let me let you get. $26 or those nurses playing cards. Tom, what are the dates for necessity?
26 to 30.
26 to 30.
You might. Yeah, so he was.
Are you able to go to like see if we're actually broadcasting? If you were to go to CSASTRO.
Tell me the dates again. Tom, 26th to 30th?
It's
Wednesday to Saturday. Sunday morning. You can pull out Sunday morning.
Of June.
Of June.
So that would.
Because you're in June. That's
Why am I in
good.
27?
Because you're forward 50 minutes.
Okay.
I show up for 2 meetings a year.
Why not? All you're doing is you're bringing 3 beer.
I will bring 3 here. The other 5 and 6. John gets 3.
The only thing is, I know I have another event in Lake June.
Dibs. Yeah, but again, I mean, one night, because it's Thursday, Friday, Saturday, and Sunday. You were always there because that's the night. We do both of
Yeah, I'm getting something to go to this.
We'll let you
John, don't worry about it.
You could stick a whole bunch together and make it.
The red shirt means it's a while to get over
We have a reputation. Oh. As much as you harass me about it, I enjoy the reputation. I bet you that's why, Vicki. I didn't have the screen moved over. I think. No, actually, that shouldn't matter.
You ready?
I think so.
All right. Should I hit the mallet?
Yeah.
All right. I'll hit the mallet.
Yeah, well, 2 seconds late. It's all right.
It took them that long to bang the
We're
gavel.
missileers, that's a good thing.
2 seconds, man.
Welcome, everybody. My name is Matt Russell. I am the current president of the Colorado Springs Astronomical Society. Welcome to our April meeting. Real briefly, I just want to go over a brief synopsis of what we're going to be doing tonight. We have Dr. John Spencer in the house. He's going to be talking with us after I'm done here. And then we are going to go into observing reports. And then Doug Cook has some stuff that he wants to talk about, as well as I think you're going to be talking about these, right?
Yeah.
Our name badges. We're going to, depending on where we are with John's talk and everything else, we'll see how long we can have a break for. We'll determine that at that time. After the break, Vince, you ready to do your what's up?
Yes.
I don't know, Scott, you guys
Yes.
know slide. Perfect, yes. We're going to be doing outreach reports if Dave Warner is here. Yeah.
Dave's here.
Oh, he is here?
Yes.
Okay. We're going to go into committee reports. We're going to be talking about our astrophotography group. One thing that's coming up, Star Stare. Some neat happenings down at Starry Meadows. Treasurer's reports, quarterly time for the Treasury report. So other than that, what I'd like to know is there anybody that's here for the first time? A lot of folks. A lot of folks. Would you mind taking a couple seconds, introducing yourself and telling us why you're here, what your interests are?
Make sure you have slides to present it.
So if you would please stand up, or whoever wants to go first, yeah, there you go.
I'm Spencer, I'm Reese's student, and I'm gonna next year at Boulder.
Right on.
We have a lot of stuff going on.
Yes.
I joined the only thing I've attended is the lunar eclipse at night, and I'm signed up for the Star Stare.
Right on.
So I'm excited.
Yeah. I saw a lot of hands back this way. Oh, all right. I think I saw some hands over this way. Yes.
I'm Mark Lindsay. I'm a physics researcher at the Air Force Academy, and I'm sort of friends with this country here, and I wanted to come and hear the talk, and I'm amazed. This is a great discovery center. I'm very impressed with it. I'll come back to this.
Perfect. Anybody else? Yes.
I'm Judy, and I moved here fairly recently, and I'm from the
Yeah. Just with all you Boulder folks coming down this way.
John also has a fan base.
Anybody else? Yes.
I'm Tim, and this is my son. Curiosity and interest.
Great.
It's all done.
Perfect. Well, thank you very much. Thank you, everybody, for coming. One thing that I don't want to forget is there should be an attendance sheet at the back of the room. If you could please sign that if you're a member. If you're not, there should be some guest cards. Are they? They're about that
They're
big,
back
little postcard sized cards, so that we can get in contact with you in the future about different things if you'd like. Yeah.
You need more. I need more? I
Guest
got more.
cards. Okay, we'll put some more up there. Perfect.
There's also some handouts back there, free to take everyone from the Parker Pro.
Perfect. I'd like to, yes.
I'm sorry, I have a question about the attendance sheet. After this, right on the.
The attendance sheet will be there all night long. Well, until we're done with
So you take
it.
away?
Yeah, that'll be it. Perfect. One thing I want to do is I want to introduce to you our board directors. First of all, we have Doug Cook, right here, our vice president. Scott Donnell over there is a trustee as well as our treasurer.
As well
As the webmaster for the evening, so he's like the
You
jack of
force
all
lately,
trades.
Scott.
Yes.
How many hats can
Vicki Kitzman, our secretary right here. Tom Olkin here. He is not, okay, he is a member at large. George White, I haven't seen. The other trustee that we have is Bruce Bookout, right over here. I really don't have a lot to talk about this evening myself, but I do have some dates that are very important that I wanted to talk to you about. This coming up, or this Saturday, no, it's next Saturday, right? Like 10 days. Saturday, May 4th is the Starry Meadows workday. I'm sure that Barry will be discussing that during his segment this evening. Got some exciting news about Starry Meadows. Sunday, May 19th. Believe me, this date will come a lot quicker than you think. This is the cutoff date for the regular registration rates for Rocky Mountain Star Steering. So if you haven't done so already, you might want to register before the rates go up about, what, 50%? 50%. They go up a lot this year. There is going to be, because of Rocky Mountain Star Stare in June, there is no meeting here in June. We'll have a meeting here next month. I will not be here, but Doug Cook will be emceeing that night, so please. A little bit. August 24th, the end of August, we have our summer picnic out at Black Forest Regional Park. Eventually on the forums, we'll talk about that and what the times are that we're going to be there. We have that same pavilion reserve that we've had in the past. And believe it or not, I'm already working with the Space Foundation for our Christmas party in Area 51. So that is hopefully going to be the beginning of December, on December 7th on Saturday. So that's that. For those of you who don't know, the Space Foundation donates the space to us. And what we do is we do some things for them in return. For example, start parties. We do an event at the Space Symposium for them. However, they provide this meeting space for us and our board throughout the entire year. So thank you, Space Foundation. We appreciate that. I am done. John, would you like to make your way up front? Yes. Thank you. All right. Great. I have a couple opening remarks, and then we can get going with John's presentation. Dr. John Spencer is a longtime friend of the Colorado Springs Astronomical Society. He has been a keynote speaker several times at Rocky Mountain Star Stare. We welcome you back and appreciate your time coming down from Boulder. John Spencer is an institute scientist at Southwest Research Institute's Department of Space Studies in Boulder. A native of Lancashire, England, he obtained a bachelor's degree in geology from the University of Cambridge in 1978 and a PhD in planetary sciences from the University of Arizona in 1987. John specialized in studies of the moons of the outer planets, particularly the 4 large Galilean moon satellites of Jupiter and other small outer solar system bodies using theoretical models, Earth-based telescopes, close-up spacecraft observations, and the Hubble Space Telescope. He has also published research on Mars, asteroids, Pluto, and Neptune moon Triton. John is currently working on NASA's Europa Clipper mission and on the Lucy mission to the Trojan asteroid. John is a science team member on the New Horizons mission to Pluto, and a deputy project scientist for its extended mission into the Kuiper belt, for which he coordinated the successful search for Kuiper belt object, the flyby targets beyond Pluto. He led the planning of the successful 2019 flyby of the small KBO 2014 MU-69, the Ultima Thule, the subject of tonight's presentation. I present you, Dr. Johnson.
Thanks a lot. And I don't want to be outdone by the Parker Solar Probe, so we also have New Horizons stickers at the back there, and you can pick them up later. And so, yeah, I want to tell you about the exciting encounter we had with this Kuiper belt object on New Year's Day this year, and all the preparation that went into that, and also a bit of background on New Horizons mission and what was originally its primary target, which was Pluto. And so I'll go ahead here. This is our spacecraft. You can see by the there's my laser pointer. Okay. You can see by the people here, it's a pretty small spacecraft. It would kind of fit comfortably in the front of the room here. But it's a very powerful spacecraft. It was built between about 2002, 2005 at the Applied Physics Lab at Johns Hopkins University, which is where the mission is run from. And it's bristling with cool scientific instruments. It's got a radio science instrument that's built into the main antenna that it also uses to communicate with Earth, which gives it uses to probe Pluto's atmosphere in particular and measure temperatures. A couple of plasma instruments to measure the solar wind. Behind the lens cap here, you can't really see it, is a telephoto camera, the Lorry camera, a black and white, very powerful telescope. It's an 8-inch telescope, which I'm sure a lot of you have bigger telescopes than that, but they're not out at 40 AU. So there. We have an instrument built by students at the University of Colorado that's a simple dust counter that when it is flying through the solar system, it will count interplanetary dust particles that hit it. And then we have our color camera here, the MBIC camera, and an infrared spectrometer, which measures the composition of ARC targets by looking at their infrared spectrum. And then ALICE is our ultraviolet instrument. It's up here. And that was mainly designed to measure the atmosphere of Pluto in different ways. But we use it for other things as well. And I'm hoping the sound works well here. You'll have to be quiet because we've got a little jury rigged here. But here's the journey's beginning.
3, 2, 1. We have a mission and liftoff of NASA's New Horizons spacecraft on a decade-long voyage to visit the planet Pluto and then beyond.
So we have a really small spacecraft and a really big rocket. It was the biggest rocket that NASA had at the time, which meant we could go really fast. And we actually were the fastest launch ever from the Earth. And we were all there cheering it on, and it was just an unforgettable day to watch that thing go. But also very brief. It was like gone before you realized what was happening. So it got that first boost from that big rocket.
3.
But then it had a long way to go. It crossed the orbit of the moon in only 9 hours. So it was really, really looking it. And in fact, it got all the way to Jupiter in just over a year, 13 months. We flew by Jupiter here in February 2007, and we got a bit of a gravitational boost from Jupiter. And then we had a long cruise out to Pluto, where we arrived in July 2015, and then on to the Kuiper belt that I'll be talking about mostly. So the Jupiter flyby, the main purpose of flying by Jupiter is to get a bit of a gravitational boost from Jupiter that shaved a couple of years off our flyby to Pluto. But we did some science there too, and it was a really nice opportunity to check out the instruments, make sure we actually knew how to fly this spacecraft, looking at real targets doing real science, and that was really invaluable experience for the team. So this is just gives you a feel for how the instruments work, what they do, or at least some of the instruments. This is Jupiter's moon Io, one of my favorite places, which is this incredibly volcanic, large moon of Jupiter about the size of our moon. And this is the LORRI camera, took these quite detailed telephoto views, and you can see mountains on the day-night boundary here. But what was striking is you see this enormous volcanic eruption on the night side. You see the glow of the lava here and this enormous canopy of material blasted out by that volcano going up a couple of 100 miles into space. And the MVIC is our color camera. It's not quite as high resolution, but you can now see the orangey color of Io, and you see the orange glow of that massive volcano, those incandescent red hot lavas there. And then the blue of the very fine smoke particles that are being blasted out above the surface. And then LISA, our infrared instrument, is measuring the heat radiation from this one volcano, which is hugely bright, but also all the other volcanoes that are active simultaneously on Io at the same time. So we've got our different instruments, we get very different views of the targets that we're looking at, and we can build up a good picture. So then it was 8 years from Jupiter out to Pluto, and we didn't pass anywhere on the way, but we were very busy. We had a cake every year to celebrate the launch, and that helped pass the time. But the main thing we were doing is planning what we were going to do when we got to Pluto. We were going to fly by Pluto in just a few hours on July 14th, 2015. We had a 4.5-hour light time interval between sending a signal from the Earth to reaching the spacecraft, and another 4.5 hours back to the Earth. So there's no way you can do anything real time on the spacecraft because it's gone past before it can report on anything. So we had to plan out every moment of that encounter in exquisite detail, exactly where the spacecraft was going to point, all of the exposure times, how we were going to handle the data, and it all had to be perfect. We actually practiced the whole thing on the spacecraft before we got there, and it did all the maneuvers, taking pictures of nothing, about 2/3 of the way to Pluto to make sure everything worked okay. And so we used pretty high-tech computer graphics to do this, and pretty low-tech wooden sticks as part of the whole thing. But it all helped us put together a really nice package. And so then in early 2015, we could begin to execute this program and start to learn about Pluto for the first time. And so this was an amazing time. Pluto takes 6 days to rotate once in its orbit. So every 6 days, you'd see the same face of Pluto, but you'd see it bigger every time, and you see more and more detail. And here's kind of a time lapse on someone's computer of Pluto going from barely more than a blob to a world which you can start to see a lot of detail, and you see incredible contrast between very bright and very dark regions. You had no idea what anything was at this point. But every day you'd see something new on this world that no one had ever seen up close before. So that was a very exciting time. And the coolest thing about it was this was the side we were going to fly by. We knew we were going to see this side close up. And it had this beautiful heart on it. And we thought was really cool. But it was such a distinctive, and we took that as a welcoming sign. Let's see. So we got there, and the spacecraft flew by and was very busy on the day of the encounter, taking all the data and not really talking to us. So the next day, July 15th, it started sending back its first close-up images, and we were all gathered around hitting refresh on our computers as fast as we could to be the first person to bring up the pictures when they appeared on the server. And I hit refresh at just the right moment, so everyone gathered around my computer to look at get the first close-up views of Pluto. And we saw this amazing view of a world we'd never, like nothing we'd ever seen before. And here's not that first image, but a beautiful global color view that we got later, showing the incredible variety of terrains on Pluto. the thing that's most striking, and here's that heart shape again. When you look up close, it's not quite so obvious, but there it is. And this half of the heart turns out to be something we had never seen anywhere in the solar system before. It's an enormous ice field of frozen nitrogen, occupying probably an old impact crater. And just as on the moon, you have ancient impact basins that are full of lava, here you have an ancient impact basin full of nitrogen. Then we have high mountains here that are kind of comparable to the Rocky Mountains, and just an incredible variety of terrains and compositions and colors and everything. And okay, now I get this movie to work. I can. So this is not direct footage taken by the spacecraft, but it is a movie taken by, let me get rid of the, there we go. Taken using spacecraft data, reprojected, but it's all pretty accurate topography. There's no vertical exaggeration. And so the scale here is very much, this is the Front Range. Colorado Springs is about here, the pole is up here somewhere. And here's the Rocky Mountains, the Great Plains. But this is a great plain of frozen nitrogen. And you can see these crazy polygonal patterns here that we're almost certain are because the nitrogen is convecting, it's bubbling and boiling like soup on a stove, but in extreme slow motion. It may take 1 million years to overturn. But there's enough heat coming from the interior, and the nitrogen is so soft that it can bubble and move even with that small amount of heat and make all this amazing geology that we're seeing here. We think those big mountains, I'll just let it run again for a little bit. These big mountains that look like the Rockies are actually icebergs of water ice that are floating in the nitrogen. Nitrogen ice is a little bit heavier than water ice. And so you can actually float mountains of ice in it. So these things are about the size of Pikes Peak. Yeah, really an incredible landscape. And then very dark regions here that are covered in hydrocarbons and tarry organic compounds. This is Pluto's big moon Charon. We discovered Charon in 1978, and it's half the size of Pluto itself, probably formed in a giant collision with Pluto, just the way our own moon formed in a giant collision with the Earth, in the early days of the solar system. So we think this may be able to tell us something about how our own moon formed in our own early history. Charon is very different from Pluto. It's covered in water ice. Pluto is mostly covered in nitrogen and methane and more exotic ices. And there's a rugged region here with quite a lot of craters. And we've given these names from fantasy and science fiction, so that's been fun. This is Dorothy crater from Wizard of Oz. This may be Skywalker crater here. This is Vulcan Planum. And Kubrick Mons here, I think. So we have a region here where it seems like the crust has broken and sunk, and some soft slurry of maybe ammonia-rich ice has bubbled onto the surface and spread out and covered things over. So another remarkable place. And then this dark region here is the North Pole, which we call that Mordor Macula. Yeah, we had fun with Sharon. And normally poles are bright because it's cold there and stuff collects. What we think is happening here is the pole is cold, but it's collecting methane from Pluto, which is escaping Pluto and freezing out in the cold, and then turning brown due to radiation. So that's our pet theory for how we get that weird dark pole on Charon. And this now is not a computer model or simulation or anything. This is a real picture taken by the spacecraft looking back as we started pulling away from Pluto, heading out into the Kuiper Belt. And I think it's everybody's favorite picture. You can now see these mountains standing up on the skyline, just like, there's Pikes Peak, there's Cheyenne Mountain. And then you see this enormous atmosphere extending way above the surface, way off the top of the picture. Pluto's atmosphere is very thin. It's 100,000 times thinner than the Earth's atmosphere. But because the gravity is so low, it extends incredibly high. And then as we pull away further, we were able to take color pictures looking back, and we see this beautiful blue rain of the atmosphere above Pluto. So like the last picture was like an extreme close-up of an area, something like that. And so Pluto was an amazing place. We were sorry to say goodbye, but we had other places we wanted to go. And so, yeah, here's Pluto. Here's our flyby in 2015. And then we're going out into the Kuiper Belt. And the Kuiper Belt is a part of the solar system we didn't even know existed until about, let's see, 92, so about 25 years ago. The first object other than Pluto orbiting beyond Neptune was found. And this is a region, I mean, I'm sure you're familiar with the asteroid belt between Jupiter and Mars. This is like an asteroid belt on steroids. There's hundreds of times more material here than there is in the asteroid belt. But we didn't discover it until the 1990s because it's so far from the sun that these objects are very far away and very faint, very dimly illuminated, and were hard to find. But now we know there are hundreds of thousands of objects out there. And a lot of this material has been undisturbed since the solar system formed and is already telling us a lot about how the solar system formed, because it's this dusty archive in the edge of the solar system that hasn't been touched since then. Well, we had one problem. It looks like here there's so many Kuiper Belt objects you can barely avoid running into one when you're heading out here, but in reality they're a million miles from each other. And when we launched, we knew there was stuff out there, and we knew there was going to be objects kind of along our path, but we didn't have a specific one that we knew we could reach. And the spacecraft just has enough fuel to nudge its trajectory about half a degree one side or the other. So that's really a pretty small area that we can get to, given that we're traveling at such an enormous speed straight out from Pluto. And so we had to find an object that was just going to be this very narrow cone extending out from Pluto. And so we organized a big search campaign, and we used some of the biggest telescopes in the world. We used the Subaru telescope here in Hawaii, the Magellan telescope in Chile, some of the widest field cameras, some of the best facilities that were available. And we searched for years, started in 2011, got a lot of telescope time, and we found dozens of Kuiper Belt objects out beyond Pluto. But we didn't find any that were close enough to our path that we could actually, with the fuel we had available, we could go nudge the trajectory and go visit one close up. So that was frustrating, and by 2013 we realized we had to do something else. And what we did was use the Hubble telescope. And Hubble is a measly 2-meter mirror compared to these 8-meter giant telescopes on the ground. But the biggest problem we had looking for objects is that not only were they incredibly faint and moving incredibly slowly, but we were looking in Sagittarius, in the densest star fields in the entire sky, because that's the direction, just by bad luck, that any objects we could reach happened to be. And so you just couldn't see between all those stars, despite all the fancy programming we did to try and subtract out the stars and isolate any moving objects. We could find a few of the brighter ones, but not the really faint ones that we knew would be likely to need to find to target. But Hubble takes much sharper images because it's above the atmosphere. And so Hubble has the ability to see between the stars, and they're not all blurring out and covering the whole sky. So you can see these tiny moving objects, and that's why Hubble was the tool for us to use. And in the spring of 2014, just a year before we got to Pluto, and a year and a half really before we were going to have to make our maneuver to fly to whatever object we found, if we found one, we applied for time on Hubble. We applied for 12 days of Hubble time, which is an enormous amount of time to ask for. And the Telescope Allocation Committee met and awarded us the time on June the 13th. And thanks to incredible cooperation from the people who run the Space Telescope, the Space Telescope Science Institute, they had things set up that as soon as the Time Allocation Committee said yes, they could basically hit the button and start executing our campaign within a couple of days, because we needed that data so soon. And so we got our first data 3 days after we got the news that we were being allocated the time. But there was a catch. They were a little skeptical that we could do this, and we weren't quite sure we could do it ourselves. So they said, okay, we're going to give you about a quarter of your time, And you've got to find some objects with that quarter of the time. And you've got to find 2 objects. And if you don't find those 2 objects, we're not giving you the other 3/4 of your time. You've got to prove that you can do this before we spend this enormous amount of expensive time. So we got right to work, and we had a crazy schedule, basically working every day. And then just 11 days later, we found our first object. And this is Mark Bowie, who was a member of our team, who really was the workhorse for devising programs for searching the data and finding it. And I got a call from him saying, "You better come down to my office. Look, I've got something to show you." And he had on his screen an image of the first object that we found. And we breathed a sigh of relief then that, okay, this is actually going to work. And the next day he found another one. So we made our quota, and they were going to give us the rest of the time. But to give you a feel for the difficulty of this, here's the full moon in the sky. This is the area we had to search in order to find, have a decent chance of finding something according to all our calculations. And each of these squares is one Hubble picture that takes a couple of hours of Hubble time to get. And so Hubble had to patiently mosaic this whole region in the hopes that we would find something. And this is a tiny piece, it's half of one of these fields, or 80 of these, so it's 160th of the area that we had to search. And here is an enlargement of this tiny piece of that 100th or less of this thing. And here, by comparing the fields, here are some stars, there's lots of stars, and here's this moving object in this time-lapse portrayal, moving across the sky at exactly the right rate to be a real object. Here, and that's what Mark found. Here it is in one of those single images. And it may not be terribly obvious, but in the next image, you can see the stars move and it is staying put. And it's right in the center of the frame. There's one more. So this is our target. So that's the kind of job that we had to do, and we had to do so quickly, and that Mark and everybody else on the team did so magnificently and found us our objects. And then we had the rest of the summer to search the rest of that whole area and also track the objects we'd found and just plot out their orbits and see if they were heading that direction. And a couple of months later, on August the 22nd, Alex Parker, another member of our team, sent this email out saying, "Hope you're sitting down, because that first object we found on that first view that I showed you is targetable." He'd done the calculations, and we could actually reach this with the fuel we had available. So that in every model he's run, it produces a probability of 100% that the object is targetable. So we then knew, after all those years and all that struggle, we actually had something to fly to. And this is now less than a year before we got to Pluto, and only about a year before we had to burn the engines and make that turn to the spacecraft trajectory. So just in time, we found a target, and we were very happy, of course. And so here it is. It got this official designation of 2014 MU69. This is now an accurate orbit to scale. Here's Pluto, and right on the straight line trajectory, or just with a slight deviation beyond, here it is. Now you notice there's lots of white objects here, and there's a bunch that are colored orange. And the orange ones are really special objects, and it's the kind of object we wanted to get to. The Kuiper Belt has stuff in it that's been pushed around by the giant planets, including Pluto itself. Pluto is the biggest of the objects in the Kuiper Belt. And Pluto has this tilted and eccentric, kind of crazy orbit, because it's being moved around from someplace else by the giant planets. But these orange objects, which we call the cold classical Kuiper Belt, are all traveling in circular orbits, flat orbits in the same direction. Nothing has disturbed those things since they were formed 4.5 billion years ago. And they must have spent that entire time at 40 astronomical units, 40 times further from the sun than we are, in deep freeze, never having been any closer to the sun. And these are the objects we wanted to visit, and it turns out MU69 is one of those objects. It's right in the middle of that cold classical swarm. So we were very excited that this was the kind of object, a pristine object like nothing we'd ever seen before, was one that we could go visit. Oh, and we decided this was a bit of a mouthful, so we actually had a naming competition and came up with a pithier name, Ultima Thule, which is just a nickname, it's not an official name. But that's what we were calling it for the flyby. And so here we are, just a couple of months out beyond Pluto. We fire our engines, change our course by 1/4 of a degree, which actually left us plenty of fuel to spare. And that put us right on the course of this guy here to arrive, just by pure coincidence, on January the 1st, just half an hour after the ball drop on Times Square. It just happened that way. We thought about spending the fuel to have the flyby coincide with the ball drop, but we thought, nah. It's not the best use of it. So then we've had nearly a decade to plan the Pluto flyby. We now only had about 3 years to plan our flyby of Ultima Thule. We had to figure out how close we wanted to get to it, what side of it we wanted to fly by. Do we fly by the day side or the night side? What kind of observations are we going to make? And where is it anyway? That turned out to be our biggest issue, because this is an object we'd only discovered the previous year. Pluto we'd been tracking for half its orbit around the sun. We knew its orbit very well. Here was something we'd only just discovered, and the spacecraft has no onboard tracking capability to lock onto a target and take pictures of it. It's always pointing blind. And so you're telling it, okay, point over here, take a picture, and you hope there's something in that field of view. And this is a telephoto with like half the size of a drinking straw field of view, if you're looking for a drinking straw. So we had to know exactly where to point, and a lot of our discussions were about how much margin of error do we place. We didn't want to just take one picture, we want to take a whole slew of pictures of all the places it might be and hope it was in one of them. And so all that had to be figured out. We had to figure out if it was going to be a safe flyby, were we having any danger of running into debris, or do we have the storage space to put everything? Do we have enough power? Do we have enough fuel to do all our maneuvers and so on? And this is the plan we've ultimately came up with. These are time ticks every 15 minutes, so we're looking at about a 2-hour period. Our target Ultima Thule is somewhere in this purple box. We don't know exactly where, so we have to photograph everywhere within this box. And as we approach, we're taking infrared, then measuring temperatures, then color, then more infrared, then our best color, our best black and white view, looking back at the crescent, night time, thermal, and so on, all the way out, including looking back towards the sun, seeing if there's any absorption of sunlight or any gases coming off this thing. We had to do all that in a couple of years, and we had to test it out and do alternate versions in case we wanted to divert to a safer trajectory. So we had a very busy couple of years there. And so it was really an exciting day in August 2018. It seems like a long time ago now, when we got our first view of it from the spacecraft. Up to this point, we'd only been tracking it with the Hubble telescope. And we had also watched its shadow. We watched it passing in front of a star. We had portable telescopes down in Argentina and in Africa, watching it wink out as it went in front of a star to measure something about its shape, but we didn't see it directly with those telescopes. Only Hubble had ever seen it directly. But finally, in August, we were able to get close enough with our onboard lorry camera, we could see it. And it was really important that it showed up in the right pixel, because we were looking at it from an angle different from the Earth. It was in a totally different part of the sky as we'd see looking from the Earth. But if it wasn't in the right pixel, our navigation was off, and it wouldn't be at all clear that we'd be able to fly by it and point our cameras. But there it was. This crosshouse is where it was supposed to be. That's where it was. And so that was very gratifying. It was also about the brightness we expected it to be. These funny things here are stars in the image that we've subtracted, and so they don't subtract perfectly. But that allows you to see this object here. If you just had the original frame with all the stars, you wouldn't see it at all. And so, beginning of December, everyone gathers for the encounter. It's Mark Showalter who was leading the search for any hazardous material around Ultima Thule. Because if we found anything, any rings of debris or moons that might be shedding debris, we could divert to a more distant trajectory that would be safer, but wouldn't give us as good science. So we didn't want to do that. And we'd done so many practice runs and operational readiness tests that we needed a reminder that this was finally the real thing. And so here's Mark Bowie, and you should have Mark come give a talk sometime, because he led that whole expedition to observe the shadow and plot the orbit. And from measuring the shape of the shadow from the telescopes in Argentina, we had some idea of the shape. So he's doing some high-tech modeling using modeling clay here of what he thought the shape might be based on the information we had at that point. And we were considering a variety of different shapes because we really, we really didn't know what it was going to look like. One thing that was puzzling us was, as we were approaching it, it looked kind of elongated and looked like a double object in that shadow measurement from Argentina. So we expected to see it brightening and fading as it rotated. But the brightness was just rock steady all the way in, and we were really puzzled by that. How can an object that looks like it's made of two things stuck together and it's quite elongated not be varying in brightness as it rotates? It had to rotate, everything rotates. But we couldn't see that. So yeah, we were trying to think of any kind of funny shape that might allow that to be possible. And there was a bar nearby where we hung out, and friend Leslie Young invented with the bar an Ultima Thule cocktail, which is kind of dark and reddish colored and has champagne because it's New Year. So we found other ways to spend our time. But the thing we were most focused on then is whether it's safe, whether there was any hint of moons or rings or any kind of debris around it. And so here now is an image taken mostly, I think, a couple of weeks before we got there. And here's our target now, very bright in the field, and we've been able to remove all the stars from the field. And we're looking for anything around here, particularly around the area we were going to fly. And we saw absolutely nothing in this frame other than Ultima Thule itself. So at this point, we knew we were able to go to fly our prime trajectory, get the best possible science. And so we had a decision meeting, and this is Alan Stern, who is the chief scientist, and really the whole mission is his brainchild, giving the thumbs up that we were good to go with our prime trajectory, and Mark Showalter, who led the hazard effort, very happily acknowledging that. And here's our mission operations manager, Alice Bowman, with our hard hats that we had for the hazard process. And then it was Christmas. We actually took a day off for Christmas, and but then it was back to work again. And our biggest task for the remainder of that approach period was making sure we knew exactly where it was. And this is illustrating. Here's one of the original frames from the lorry camera. You just see a whole bunch of stars here. This is a processed version. And as we go through this, as we get closer, you see one of the stars starting to move and moving faster and faster and getting brighter and brighter. And here you've removed the stars, so it's really obvious. And you can just barely see it here. These are some of those earliest images. And so here's our target getting brighter and brighter, and we're measuring its position as accurately as we possibly can to make sure we're on target and that we'll be able to point the cameras the right way. And we made several tweaks to the trajectory as we approached. And there was a lot of very intense discussion about this. We looked at a lot of plots like this, if you can see this. This is basically looking at the sky that we're heading towards. This box is where we want to put the spacecraft, where we want it to fly through this box in space. This is where we think the spacecraft actually is at this time. It tells us that we're off course a little bit. So that's telling us we need to do a maneuver to fire the engines, move the trajectory back into this box. But you see different colored circles here. These are different estimates of where we are, and they don't quite agree with each other. So before you correct into this box, you have to figure out which one of those you believe. And so we had really intense debates about this, and I just found this whole process fascinating. And to me, it felt just like Captain Cook must have had these exact same conversations in his cabin when they were trying to find New Zealand. That, where are we? What's our current longitude? How accurate is that? Could we be if we're drifting, why are we drifting? Where's New Zealand anyway? And so you really felt a connection with those guys here sitting in our comfortable conference room, doing exactly the same thing that us explorers have done throughout history, trying to figure out where they are and where they need to go. So this all came down to the wire 4 o'clock in the morning, 2 days before we got there. Because the best information you get on where the object is and where to point your cameras is as late as possible. The closer you are, the better the information you get. But if you're too close, it's too late to send a signal to the spacecraft to do anything. And so the sweet spot when we could get the information, process it, and send up signal to the spacecraft was 4 o'clock in the morning, 2 days before the encounter. And so we're all there, having just made the decision that yes, we're going to tweak the spacecraft pointing a little bit. The spacecraft team could then go off and design those commands, send them out to the spacecraft a couple of hours later. And then by that time, it's 6 hours at the speed of light for the signal to get to the spacecraft. 6 hours to get an acknowledgement. And then if it didn't work, you need to have 6 hours to send it up again. And so at that point, we all got home and grabbed a little bit of sleep because things were going to get very busy. On the next day, in fact, the next morning, I woke up at 11 a.m. I slept in a little bit, and the first thing I did is grab my computer, started downloading the latest pictures. And finally, after all these months of just looking at a dot of light, we could start to see the shape of it. And indeed, we saw it was really elongated like this. This is the original image, and this is after a lot of processing. We can sharpen it up like that. And this was, again, puzzling because we weren't seeing a light curve. It was not varying in brightness. And the best we could tell is it was actually this, if I can get in there, not much light here, but it's spinning like this, end over end. So we always saw as much like the same face, but it was still rotating. And then the next morning, this is now just, well, next afternoon, this is just about at half a day before the flyby. We started to see that there was actually a narrow bit in the middle. So we had a thick bit, a thin bit, and a thick bit again. And it was about 20 miles long. And we could start to get some real feel for the shape of it. And then the spacecraft got very busy doing its counter maneuvers, and we didn't hear from it again until the morning of January the 1st, when we got the news from the spacecraft that it had successfully completed the flyby. It gathered all the data it was supposed to. There were no onboard anomalies. Everything had gone smoothly. So then we had our big celebration. And here's Jane, who's in the back, and other friends of ours. Our friend Mark was there as well, helping with the celebration that we knew we had a successful encounter at that point. The other thing we'd learned is from those last images taken after it was too late to do anything about it, that indeed it was right where it was supposed to be against the star background, which meant we were pointing exactly in the right direction. So we knew at this point we had it in the bag. We hadn't seen what it was going to look like, but we knew it was in the bag. And so now we just had to wait for those first pictures, close-up pictures, to come down. And so that afternoon, the science team gathered in the science room, and it takes about an hour for a picture to get back from, it's taking 6 hours in transit, but an individual frame takes about an hour, which means a frame would fit kind of between the orbits of Jupiter and Saturn. But it comes in slices. You get the bottom of the picture and then gradually get more of it. And this is the first slice. This is all of the picture we have. This would be the full frame, something like this. And that was thrilling because we saw this smudge in it. And this is an artifact of the camera that tells you there's something in the picture. We're not pointing at empty space. There's something there, and the smudge was about the right width. And so we knew we had really nailed it and that all of those expectations were correct. And then it was the same game. Everyone's hitting refresh on the computers as fast as they can. And this time it was our colleague Stuart Robbins at the back of the room who yelled out, "I got it!" And just pandemonium, everybody gathered around him to try and get this first glimpse of what it looked like. Here they are from the other side. And you can kind of see it on the screen there. But this is now what it looked like in that first detailed image. And yes, it's two objects, just like it appeared to be from the occultation shadow. And yeah, they're stuck, whoops, they're stuck together. And I'll show you a better version of this in a minute. But we can clearly see these two weird-looking blobs stuck together. And it was right in the center of the frame. We completely got the pointing perfect. So that was awesome. And we saw lots of hugs going around. It was a very happy moment. And so here now is Mark and a printed out version of his shape model, and boy, it looks pretty darn accurate compared to what he thought it was going to be. So he was happy. And here now is that first image with a bit better processing. And there's a smaller piece, and we call this, sorry, a larger piece we called Ultima, and the smaller piece that we called Thule, because we weren't very original. And you can see this weird bright color where the two of them are joined together. And so then we knew we had this weird binary object, and that this is one of hundreds of thousands of pristine objects at the edge of the solar system. And we already knew, or immediately knew, this is telling us something fundamental about how planets are built. To build a planet, you have to take small things and stick them together to make bigger things. You can, if they come together too fast, they'll just smash into smaller pieces, and you'll just make a bunch of debris. You'll never make a planet, and we wouldn't be standing here today. We'd have nothing to stand on. So this whole business of bringing things in gently and having them stick is key to building planets. And here we had our first example of that process frozen in time for us to look at. And so, though that proceeded to be a lot of arm waving, trying to explain this and understand, looking through all the literature of how objects will collide and stick, and trying to see what might be consistent with our observations. And some things work, some things don't, and we're already starting to learn more about how planets form. But then we just had a couple of fuzzy images, and then we had to be patient and wait for the downlink. Since then, the spacecraft will be sending the data back to Earth. It's going to take through 2020 to get every bit down. But we have already got down most of the good stuff because we prioritized it. That's been one of my jobs the last few months, is prioritizing the data, making sure we get out the most important stuff first. And so most of the best data is now on the ground, and we're still getting down filler information. And so what have we found? One thing, we now have an actual movie of it rotating on approach. And you can see that indeed the pole is facing us, so we're just seeing the same side spinning around. And we've scaled these so they're all the right relatives, the proper relative size. So you see it getting sharper as we get closer instead of getting bigger, because we just enlarged the earlier images. And you can start to get some idea of the three-dimensional shape from this. And our first picture was it was two spheres stuck together. But we can see from this is actually two kind of flattened things, and not spheres at all. And it told us that the rotation period was 16 hours. Also, this was one of our best image from January the 1st. This is just one image. We actually took about 40 of these, and we were able to add them together and improve the exposure and improve the sharpness. So though this is basically the same view taken at the same time, it's a way better picture because we're able to add all those images together and sharpen them up. And now you're really seeing these two components and the bright color in between them. This is now our closest view, where we're looking a bit to the side, and now we can see craters and other features along the edge here, and what look to be other bright spots, and all kinds of weird patterns here that are hard for us to understand. We've got color now, so this is our best color image, and we can combine that with a simultaneous black and white image and get this view here. And there are color variations on it. The first thing we learned is it's very red, and which is good news because it's exactly the right color to be one of these co-classical objects. They're all about the same color. It fits right in the middle of that distribution. So it really is the kind of object we wanted to find. But there are subtle variations. You can kind of see here, this area is a little bluer, this area is a little redder. Yeah, so it's made of bits that aren't all quite the same color, telling us more about how it was put together. And then by combining views taken at different times, we can make stereo. And if anyone is good at doing cross-eyed stereo, you might be able to fuse this to make a three-dimensional view. I tried doing it with the red blue glasses, but we couldn't get it to work very well. So I'm sorry if this doesn't work for you. But I know some people are good at that. But this animation between them gives you some feel as well. And you can this bit is actually pretty flat. It's more like a hamburger patty than a sphere. And this object, even though it looks kind of spherical, is already pretty flattened. So these are weird shapes, and this is nothing we expected at all. And then we had a view looking backwards. Here it is moving across the camera field of view with the star background. Yeah, and though we never saw the far side, we were able to get some idea of its shape because you see the silhouette of the stars behind it. You can see where it's blocking the stars and where it isn't. And so that tells us it's flat on the backside as well. And here is that image actually sharpened up. It's blurred, but we were able to sharpen it up and make this beautiful crescent image here of the two lobes. And so we thought originally we were dealing with a couple of spheres stuck together like this. It's actually more like this seen from the side. And we think now it's probably a little bit fatter. It's more like this. At that time, it could have been anywhere in this range. We've got new data since then. But it's still a pretty flat, like a thick hamburger patty. And then there's maybe a walnut-shaped thing that it's stuck to. And how does something like that form? Well, what we think is happening, and the reason you can stick these things together, and this is a theory that's been around for a while, and we now have evidence for it, is that you have a lot of dust and gas, like you've always heard of, that the solar system formed from. But the dust, it gets caught in eddies in the gas. The gas is swirling around, and in these little whirlpools, the dust will collect, and eventually can reach the point where it starts to have enough gravity to start falling together. So you can go from dust particles, just sand grains or pebbles, we like to call them, into things that maybe are approaching the size of Ultima Thule. And they're going to swirl around and start to come together under their gravity. But because of all the gas, they're going to come together very slowly and gently. And they don't blow each other apart when they collide. And so eventually you might get two objects orbiting around each other like this. And in fact, we do see a lot of Kuiper Belt objects where there are two discrete objects orbiting around each other. But somehow by processes we don't understand, these are losing momentum, losing energy and falling gradually towards each other until eventually they just kiss and lock, and they've been like that ever since. And so yeah, for the first time we're seeing how the planets were built. Just this instant frozen in time after 4.5 billion years, and that's really exciting. And so that's really all the science, but just to end, the cool thing about this business is you get to meet all kinds of interesting people because everyone's interested in what we're doing, and a guy who's particularly interested was Brian May here. If you've seen Bohemian Rhapsody, you know who he is. He's the lead guitarist from Queen. He still plays with Queen, but he actually has a PhD in planetary science. He was in grad school when he was playing with a band and for a hobby, and the band kind of became this super rock group, and so he gave up his PhD, but in 2007, he went back to Imperial College London and finished his PhD. So he's now Dr. Brian May. He's very interested in stereo photography. He's actually designed his own stereoscope, and he was helping us make stereo pictures for the encounter. But one of the fun things he did is he wrote some music to go along with the encounter, and you can find this on YouTube and elsewhere. But we worked with him to put together a movie of the whole approach sequence using the actual data that we took, but filling it in so we got a nice smooth movie, and he provided a soundtrack for it, and we were working very closely with him, and it's pretty interesting. I got an email from him that would have been 3 o'clock in the morning his time. I said, "Don't you ever sleep?" He said, "Yeah, well, I got to do this thing with Prince Charles today." So it's an interesting world. But anyway, the final movie that we made is coming up now, and this is a good way to end, I think. And again, hopefully the sound will work. So this is the initial star field we saw on approach. One of these dots is Ultima Thule on the approach. And we actually have an emission nebula here and the dust cloud here, so it's quite an interesting field. But you see it emerge from this star field as we approach. I can figure out how to do this.
explore mientras cuida de su hermano.
Short and sweet. So yeah.
Say we're still downloading data.
Mhm.
What kind of data is coming down now?
Let's see, right now, this week we got back some of the rotation, some more of that rotation movie. We took a couple of dozen frames of it as we were approaching. We got back a smattering of them early on, but now we're filling in that movie, and that will give us the best possible information on the three-dimensional shape. We're getting down data looking back from behind to see if there are any rings, any dust rings that might be scattering light forward. We're just talking today, we'll be getting down some of the data, the ultraviolet data, looking at the sun through any gas that might be around Alta Matula to see if there's any gas there. We don't expect rings, we don't expect gas, but it was our only shot at it, so we wanted to do everything we possibly could. So that kind of stuff that's coming down at the moment. Yeah.
What's the contingency plan for you guys?
Well, we've got to get all our data down, but we're also continuing to look. We're still in the Kuiper Belt. We have our distant objects that we're looking at. And I didn't talk about this, but I mentioned early on that we found, several dozen additional objects that were too far away to fly by, but we were close enough that we could image them from a few million miles away. And that we can image them from directions that we can't see from the Earth. We're close enough that we can see if they have small moons close in or something like that. We could see things like that we would not be able to see even with the Hubble telescope. So we're looking at those objects as well. We'll be looking at some more of those this summer. We're continuing to measure the solar wind as we go out from the sun. We actually just today got back some images we took looking back at Pluto. We're a billion miles beyond Pluto. But we wanted to see if we could still see it, to see if that bright ring of haze, which would just be a dot at that distance, had changed in brightness, because the atmosphere might have changed in the last 4 years since we were there. So we're doing that kind of science. And we've been thinking about, can we find another object to fly by? But that's really difficult. We haven't given up on that yet. We're still exploring options, but that's going to be a long shot.
Is there any sense of, in 4.65 billion years, how long ago those objects came together? And when they come together, do they freeze together? Do they melt together? We don't know.
We don't know, but we think we know when it happened. Because the only time it could have happened is when there was still a lot of gas and dust around. And we know that dispersed after a few million years after the solar system formed. So really, this happened 4.6 billion years ago. And really, nothing has happened to this system since. And the fact the orbit is so undisturbed, and we know it's been that cold for so long, this all reinforces that picture. So we're really seeing the beginning of the solar system here.
There's adhesion, it's not known.
We don't know about the adhesion. There's that white color that connects them, and that's very intriguing.
Spackle?
It could be the spackle, but it could be they're just resting on each other. But it's probable that there's some sintering happened and they glued together over this time, but we don't really know for sure. And we don't know what that bright ring is, so we have a few ideas. Yeah.
Do you know why it ultimately iron?
We don't think it's iron. I didn't mention we took infrared spectra as well, and we have a spectrum and it shows some water on the surface. It also shows methanol. And we know that red color, we're pretty sure it's due to carbon compounds, organic material in the sense of being complex carbon molecules and hydrocarbons and so on. And so we see that red color in many places in the solar system, and we think it's often due to that cause. So some people think it's iron in some places. Out here, it's hard to imagine a lot of iron, and it's almost certainly those carbon compounds. But we don't know why, of the Kuiper belt objects out there, those that are in the white in that original plot I showed that have a bunch of disturbed orbits that have been pushed around, there are a whole bunch of different colors, but all the co-classical ones are the same shade of red. And so there was something very uniform about conditions in that part of the solar system that produced red objects. And hopefully by understanding this data better, we can get some clues as to why that is. So, yeah.
I was just wondering, I'm a student right now, and I was wondering what the kind of educational background of everybody in your team was. Were there people of varying degrees?
Yes, most of us have PhDs in either astronomy or planetary science, sometimes in geology. One thing about studying the planets is that it's convergence of physics and astronomy and chemistry and geology and biology if you're into looking for extraterrestrial life. So there are people with a lot of those different backgrounds, and my original undergraduate degree was in geology, but then I got a PhD in planetary science that combined those. And then, of course, we've got all the engineers as well, who make this whole thing happen and are an essential part of the whole process, and who have engineering degrees and computer science degrees, and so all those different backgrounds that we need to make this thing work. Yeah.
As a artist, I loved the idea of them sculpting the idea of like what they thought it was.
Yeah. Mm-hmm.
And I was wondering if there's similar your storytelling. I love that.
Yeah, and we love that too. You can use CAD software and manipulate things on the computer, but that can actually be kind of clumsy. There's nothing like getting your hands on a piece of clay and molding it. And there were some people who were quite artistically inclined who were on the mission who were really into doing it this way. And then we cheat. We'd take our clay models and we'd scan them into a computer and we'd make a 3D thing in the computer and then make printouts of that. So you go from real to virtual to real to virtual again. Yeah. And then of course doing something like that with Brian May, and he's bringing the music to it and saying, oh, this is how to make a real impact out of this, and here's when to make that transition and have that be effective was really fun as well. Yeah.
One of the things of many things that's phenomenal is the software that's involved, the math of the software, but especially that part of it, the framing, what you have to do that far out, the long delays involved in doing it, and then the post-processing you did for sharpening. Mm-hmm. And it's an amazing software. Wondering if something along the lines of when you released Fixed Delivery years ago, will some of that software be available?
Most of it is available in various. Well, I mean, the code that tests the command sequences probably wouldn't be of any use to anyone else. Though I think there are public software that will simulate those kind of processes. But the kind of image processing tools we use are mostly ones that are available to anyone. We're using public algorithms, or we're using our own implementations of well-known techniques. So we're not doing anything particularly magic there. And some of the best stuff we've done, like that morphing between those two stereo images to produce that little animation, and also in the one I just showed, some of that's done by an amateur in Russia who is really into this stuff. And we release the images as soon as we get them and process them. And then the amateurs go grab those images and they do things with them that we don't know how to do. Like we have not been able to make that three-dimensional morphing work as well as he has. And yeah, there's a lot out there, and there's a lot of times that amateurs out there have been able to help us with some of these techniques. And then all the raw data is going on an archive, the planetary data system, nicely documented, so anybody can go there cold and read the documentation and download the data and the software to manipulate it and do whatever they want with it.
Don't underestimate amateur astronomers.
Oh, never. Yes. Yeah, so it used to be amateur astronomers would have their telescopes and they make their observations, but now there's amateur, maybe not astronomers, but space enthusiasts who do it all with a computer and still do amazing things and can make new discoveries that way. And yes.
Are there, you mentioned methanol and water, are there any other specific molecules that you guys have found by the infrared spectroscopy or any other way they look violet?
Yeah.
Any specific molecules that would make color or any other molecules like ammonia or nitrogen?
Not so far. But with the infrared data are really tricky to deal with, and we're still improving processing and trying to get the best possible spectra out of them. So we might find other things with more processing. And we can also get some idea of how they vary across the surface because we have multiple pixels on the object. And then there's a lot of lab work to be done, and that is being done to take possible mixtures and irradiating them to simulate what cosmic rays will do form to try and match that color. And then just going out with telescopes and surveying, and people are doing this now, surveying hundreds and hundreds of other Kuiper objects and measuring their colors in ways that in some ways are more precise than what we can do with the spacecraft. And trying to build up the big pictures, what objects have what colors that are in different orbits and so on. And so we're working on piecing that together, but there's still a lot of work to do on that.
How healthy is the spacecraft?
The spacecraft is in fabulous shape. We do, every year we do a trending review where we look at the latest data and how sensitive is the camera, how, our flat fields, what are the voltages looking like, and everything is just a really boring flat line. So we have, the one thing that is starting to limit us is power. We're powered by plutonium. There's actually a picture of our spacecraft on the wall right there through the porthole. And the black thing on the bottom of it that looks like a hair color is a plutonium power supply that is just generating heat, and we use that heat to generate electricity. It's not very sophisticated, but that plutonium is decaying. We're now down to about maybe 3/4 of the power we had at launch. And in 20 years or so, we just will not be able to operate the spacecraft anymore because we won't have enough power. So that's going to be the ultimate limit in the mission. We'll still be able to talk to it at that point. We just won't have the power for the transmitter. So, well, we could talk to it, we can transmit. So the distance isn't the problem, just the wattage. Yeah.
At what point do you get past where Voyager is?
We will not catch up to Voyager. We're heading in the same direction. We're chasing as fast as we can. But we launched faster than Voyager, but the Voyager's cheated by flying very close to the giant planets. And they picked up a lot of speed by doing that. And we flew past Jupiter, but not very close. And so we'll never catch up to the Voyagers. And we probably won't get that far out because they had 3 RTGs, 3 of these plutonium power supplies. We only had 1. And so our power will run out before the Voyagers. And even the Voyagers are getting close to the edge now of not being able to operate them anymore. But right now we're at 45 astronomical units, and Voyager 1 is at 125 or something like that. It's way up there.
A little bit of a head start.
Yeah, and we got a 30-year head start. Yeah.
Mentioned that possibly good for another years, but then we're down to the data, or send data.
Yeah, that's not a problem. We, with the Deep Space Network, these huge radio telescopes that we have scattered around the world, we'll be able to communicate to it as long as it still has power to listen and carry out our instructions. So it's incredible. The thing is, the transmitter has this 60-watt power, and we can hear it and get data down at kind of 1980s dial-up modem speeds, 1,000 bits a second. From that 60-watt transmitter over 44 astronomical units. It just is mind-blowing to me that that's possible. Okay, well, thank you.
Awesome.
Thank you very much, John. As a token of your appreciation, we have a highly coveted, extremely rare, Well, it's so rare, we actually don't have one here today. Mug that you will be receiving in the mail sometime. When are you mailing that? Tomorrow? Perfect. Thank you very much. We appreciate you coming down here and taking the time.
And don't forget the stickers.
Yes, the stickers.
There's more.
What we're gonna do is we're gonna take a 15-minute break, so we'll come back at the top of the hour.
Observer reports?
If you order ID cards, either the last two meetings, I have them up here.
I am. Tennessee? Yes.
Unfortunately, okay.
See you again, John.
I'm gonna prospective student receive over.
Awesome.
But I'm getting my associates right now.
I'm in everybody's way, sorry.
Expensive, so I'm trying to get my associates and that exam the way for women, page rate, space engineering, ethics, and, do you teach up at CSASTRO?
I don't know. Well, I have given a few classes once every couple of years.
Let's see all your
That's really cool. Hundreds of like there who do. Oh, yeah.
Check it out to CS.
Yeah.
CSASTRO.
For a soccer lecture. And then I was watching,
It's still 34 years. Still $30 a year.
I haven't looked at that, like, celebrity eggs. I do have looked at that, but thank you so much for your talk, and I have my kids on.
So, okay, now, are you a new member joining, or is this a reading? Okay, so you already have your
Fun
set up.
and follow your passions and all that
You have
stuff.
to do anything there, I don't think.
Which
I've been able to learn it still.
the one thing I
Right,
know from my own
if you
experience
find there's
is
some issue.
I always wanted to be an astronomer.
I'm still learning the job.
But I gradually ended up getting into geology, which was great. But then I just started following everyone else who was quite
Get that fixed.
do geology research, which when I really still wanted to be an astronomer, and it took me a couple of years to figure that out. But no, remember that's what you actually wanted to do.
Yeah.
And to then change course and say, no, that's what I want to do.
Okay.
Find a way to do it. So, and that's the thing. It's okay to. Change course.
I doubt this is it. All right, yeah, it's not the right one. I'll check that for you. It's just the one that Steven had up there. I can take it down.
The closest
Yeah, me too.
because right
You want to go over the restaurant?
Okay, these are all my receipts, and I've got a spreadsheet that's got them all numbered, so I'll just give these to you. The one, the original for the excavating of the top, and one thing I did to make it real easy to verify, that you've got that one, but there's the original.
This one's been paid.
And then I numbered all the receipts and all the line items are here, and I split out any shipping or tax I had to pay. There was a couple of them, like when I went to get the concrete blocks, and then we opened an account before they gave me a break, but they cut the price lower than the tax, so I came out okay. So you can just go through these and it shows everything. That's the spreadsheet, and then each one of them's numbered up in the corner. The only thing that's a little weird, number 10 is split between the observatory project and what's over here. 10 between the observatory project and the town hall electrical. They were thinking, I got cable folks for the observatory, so that's why they're in two different places. But that's about the only weird thing.
Yeah, for me, I don't need to necessarily, for me, I don't need to break it out like this. This is all the capital improvements.
I just wondered if, especially if a trustee wanted to look at it and say, where do we spend our money, this kind of shows.
Absolutely.
And I've got this in soft copy as well, so.
Yes. So,
Would you like me to email you a link to that? I'll give you a link, you can just go pick it up. That would work. Any questions, just let me know. My address is on the front of the envelope. So you can just, unless you want to write me a check now, I don't care, whatever works for you. So I didn't want to bug you too much because I know you got a lot going on.
Always got stuff going on.
I know you do. I've got a couple of photos that I want to show as part of my presentation as well.
Oh, you got photos.
Just two. This is land 1 and land 2, so you know which order to put them in.
Somebody's
This has got to be complicated.
It's not my cup of tea at all.
Frank never helped you with the setup, grab me. Do it.
I wanted to.
That's awesome.
Now, this receipt is not part of this.
No, you'd already paid that.
So that's the amount I would like to.
That's correct.
Okay, so just as a quick, here's how it works.
Oh yeah, I can upload it for you.
So here's, well, no, this is on my computer. So you would be able to do that. But I have all the receipts. So like obviously 4 would be the detail and budget. Expense ledger, so here, breakdown construction, right? Check number and then the receipt.
So I just set it up to where, you know, it's pretty self-explanatory. Anybody wants to look at it, they can. If I'm spending somebody else's money, I'm going to give more detail than I have to.
I think what I'm going to do is I'm going to, you can just either send me a link or email me
the PDF that has all the stuff in it.
Exactly.
Exactly what I have.
So just email me the PDF. They can all be together. I'm just going to plot this as one expense with all the detail. Is this be part of the PDF?
You bet. Yeah, I just wanted to make it as, just as easy as possible for you. You got a lot going on, you get ready to travel. And then I just have a few more expenses. Good news is it appears like we're going to come in really get everything we want and should be in good shape on the wires. We thought we might have to cut back on some, but for now it looks pretty darn good. So I'm excited about that because I didn't know exactly where we're going to be. I'm just glad to see that $700 not go over on the excavation, because that's one thing that's good. He was really good, very efficient. This electrician's really cutting us a big deal. When I cook them lunch and stuff, hey, that's all it is. He's a hard one to get all.
Okay, how do you want me to make it check now? How do you want me to make it check?
Oh,
B-A-R-Y.
yeah.
Not very young, LTD.
It's so fascinating. I ask you questions.
Oh, that's one.
I'm so glad we got this. I see it.
Yep, just chill. Oh, that's fine.
It was very special to me, especially since I'm the same one that I saw. Actually, I think it's even better.
Yeah, there is, and this is an interesting difference that, because everybody's heard of Pluto, and you tell them you're going to Pluto, and everyone understands that, and they want to see what Pluto looks like as well. If you tell them you're going to the Kuiper Belt, or 2014 Henry 69, people have no idea what you're talking about. So there's a bit more explaining.
Appreciate it. Okay, if you want a copy of those, I'll take my memory card. Thanks again for coming, I sure appreciate it.
So happy to do this.
We had a lot of things that I was back there in the back of the room, I'll tell you.
Okay, so, you want
Just
these
land
to,
one and land two, and you can show them as I'll just say, go ahead and show them. Show them we're making some progress. It's going to be, electrical go in, Monday, Tuesday, maybe a little bit of Wednesday.
already, good.
Well, you've probably got a link to my master budget on what we're doing.
Maybe I do, I haven't gone through it.
If you ever want to see it, I'll be glad to send it to you. I'm trying to track all that stuff best I can for you. It looks really good. I'll be out of here. Good to see you, Scott.
Good to see you too. No, I think we're all set here.
Any questions, you just email me.
Yeah, no, just PDF with the electronic stuff.
I'll do that.
And,
I'd rather have a link or a PDF.
So I'd rather have the PDF because ultimately what happens is
Oh, yeah, I do. Yeah.
so ultimately I put the receipts and invoices up here along with updated budgets. So I manage this. Nobody else touches this except me.
Sure.
But it winds up pretty careful so that everybody has
I'll just see that everything goes to you.
everything come to me.
And I've got my budget sitting up there so the group can see it, so the committee can see it, and they can see really what we're doing and what's been bought and all that stuff. I've got the lion's share done, so I'm pretty excited about it. I think we're coming right along.
Okay.
Thank you, sir. Appreciate it.
You're welcome. Appreciate
I've never had one. I haven't
Be quiet.
Yes.
it.
I'm wonderful. How are you?
Doing fine, thank you. Glad you got that telescope back first.
Yeah, me too. Thank you for us.
Did you get my emails or phone calls I was trying to nag you.
Oh yeah.
I thought maybe it worked.
Oh yeah. He and I when we saw each other, I told him that because I jumped off the telescope and then I told him I'd bring because I forgot my keys. I told him I deeply apologize.
I'm just a procedural guy.
No, I understand.
So it's like, I got always like, I'm hitting that all the time with like, hey, we gotta make sure this gets done. You know, now I'm reviewing their insurance policies, it's like, these little things sit up. And I go hit people and say, hey, so that's just me.
I understand, but that was a key piece that should have been late better.
Here's the nice thing, it's glad to see that.
Happy to be here. And I have a question. So, because work got so busy, and I had a freelance coming in with my members, I was wondering about
Yeah, probably the best way actually is to do the pay by PayPal. All electronic. You don't need a account, you just but it'll all be electronically things. Like when I get checks, it's all mechanical, so just go online, and I think you just be creating a new member.
Okay. Awesome. Thank you so much.
I haven't adjusted it a little bit here, but we're going to do observing reports.
Okay.
And Doug's got a couple of minutes. He wants to say something after observing reports.
Right.
And then outreach. Outreach is not going to be here.
Okay. Yeah, we'll have to. Yeah, we're gonna have to get after the meeting. We can talk. So I've got after the meeting. I've got to get with her. She wants to. She's got treasurer business for me, but I can't do it right now. Don't let her go.
Okay. Well, what we're going to do is we're going to start where we left off, and that the first thing we're going to do is observing reports. Does anybody have any observing reports that they would like to share? I know that we have a couple. Come on up.
Oh, is this the? Hold it.
slides.
Wait a minute. Hold on. Okay, so this one right here.
That's me.
That's you. Okay, then.
What is it? Just the photos.
Just the photos. Oh, just the photos. Okay, I've got that.
I didn't have any slides or anything like that.
Going to turn off the lights.
There we go. Now, you can't stand right there because I have to be able to see that screen to move the, I think. Yep, there we go.
All right, here we go.
I'm going to start here with the please. This was taken on March 20th through the loaner scope that I'm borrowing from the club. It's 1/16 of a second at ISO 1600. And that was 5 minutes and 7.
I missed the first part. Is that through a telescope or just a camera?
Through a telescope, 120 millimeter scope, 1,000 millimeter focal length. The camera was a Sony A7R2.
Is that the DSLR?
Yeah. The mirrorless is perfect.
Next one.
This is taken on January 4th. We were practicing for the eclipse. And if you look down between the power lines, there's a little spot. That's Mercury. Totally coincidental catch there. Single shot. No processing other than conversion to a JPEG.
Very nice.
It's taken with a 90 millimeter lens, 1/5 of a second, f4, and ISO 800. This is taking a Mesa overlook, looking over Garden of the Gods. See Orion, a little bit of the nebula there. And then in the upper right corner, the Pleiades. That's a 15-second shot.
Oh, there we go.
I have a 24 millimeter lens.
Single shot.
Single shot.
In daylight.
No, I believe that's the f2.8 shot.
And that's just on a tripod, right? It's not tracking.
Yeah, no tracking, just sitting on a tripod.
Next. Okay.
This is
Sorry.
basically saying we moved the camera a little north. The only difference between the previous shot and this shot is this is an f3.5,
Previous one was what?
an f2.8,
What was your ISO?
1600.
Can you go back to the last one again to do a quick to show that difference again?
And we'll tell the time of
These were taken at 8:38 and 8:43, respectively. What was the date? On April 4th.
We went over there after the
After the beginner astro group meeting. Just set up the tripod and took some pictures. So. We'll do one more. And this is the equinox moon. Taken on March 20th at 7:58 through the lunar scope. This is 64,000th of a second. And ISO 1600.
Okay.
Thank you very much. Awesome.
Who's next?
Doug, do you have something along these lines?
Yeah, I do. Are there any other verbal?
I got a verbal one. My name is Mark Carter. I haven't been here in a long time, probably 15 years. I know Bruce from various outings and stuff. If you saw today's Gazette Telegraph, my photo was in there as a photo of the day. It was taken Friday of the April pink moon. So it was sitting right over Pikes Peak, and I took a picture Friday morning, and they published it in the Gazette today. It's
Nice.
pretty cool. It was, I believe it was ISO 200. Probably, moon is really bright, so it's, the exposure wasn't very long either. I can get you all the thing. And maybe next time I'll bring actual pictures.
Yeah, absolutely. Absolutely.
Okay. What I'm going to do here, I just, yeah, that's fine. Turn that off. I spoke with Matt, and now that we've had a little more time in our meetings, would encourage people, if you want to put together about 5 minutes of what special equipment you've got, or like what we just saw, some of your own astro photos we can share instead of strictly all verbal observers report. I think some pictures go a long way. And this I wanted to tell about my journey with a new telescope. I've wanted a bigger light bucket for a long time. I know my limitations of what my back can handle. I know my limitations of what will go in my car. I've had an 8-inch dot forever. That's where I'm going to get to after the sunspot, which we're at solar minimum. Every 11 years we have a solar minimum sunspot cycle. And most days we're not seeing any sunspots. I've got a PST and you occasionally see a prominence. Wow, we had a sunspot just a week or so ago. It was from the 9th through the 19th. Here's what an amateur took as the sun rotated. It's a pretty big sunspot. It was throwing off B-class solar flares. And if you've got a really good solar telescope, that's what it looked like. And there is that sunspot versus the size of the Earth. So the sun's fun to look at if you have the equipment to do it. So I got an Orion XT12G. It's a go-to telescope. I've never had one as an observer. I've always wanted one. I've learned the night sky. I've always just done star hopping to get to the objects. And I wanted to point this out to the beginning amateurs. I don't know the night sky. Well, buy one of these. You can get apps from your phone, but I think you're doing yourself a disservice unless you get a planisphere. Simple analog thing, you rotate to the date and time, and that shows you the entire night sky and the brightest stars and constellations. You can learn the night sky, how to get around.
Oops, sorry.
That's all right. So you might think, oh, this is cheating. Telescope's going to tell you how to go to. Well, when it works, it works. And okay, it arrives, you have to put it together. This is the base. It's got dual axes.
Sorry.
Dual axes, so you can track the objects and go to any object supposedly. Well, the base didn't work correctly. 360 degrees is supposed to be 360 degrees. Well, it told me it was 320. They sent me a new base. You can actually talk to the people on the telephone, which is good. I'm not advancing. So next one. Okay. The next thing I ran into as a problem is I added Sky-Fi to it. I want to be able to use my phone in Sky Safari to be able to go to objects. Connection failure. Can you call Sky Safari and get it fixed? No, you got to go to their forums. I guess it's forwarding now. And I learned that if I turn this button to turn off the automatic set time and location, it might work. So in my garage, I got a connection. Next time it's clear, I hope I can use Sky Safari to control my scope. So now following up on this, there was inspiration about spring galaxies, the Galaxy Zoo. That was the first thing I was going to attack. The Leo triplet. What's the Leo triplet? Well, Vince talked about it. Beautiful combination of three galaxies, and then Markarian's chain. I don't believe you mentioned, but that really was awesome to me. This is the quasar that we talked about that is visible through amateur scopes. There's Leo triplet from I didn't take the picture, but it is visible from Colorado Springs in the city limits from my driveway. They're 9th and 10th magnitude galaxies. They're not as bright as M81, M82, but pretty easily visible in the scope, and I never would have found it without the go-to. Now, Markarian's chain is not too far from there. M84 and 86 are similar magnitude, and what a beautiful lineup of galaxies, and you can just picture the dark matter holding these galaxies together in the supercluster of Virgo. And in the news, about a week ago, the black hole image comes from the core of M87, and they didn't ever talk about that on the TV. But that's right there, all in the same image. That there's the credits for the image up there. That's about the view of 50 power, and so you can sweep through this area in just a few grabs of an eyepiece. So there's M87. It's the radio object Virgo A and the radio telescope, and that, of course, is the news-making image, direct image of the black hole at the center of that galaxy. All big galaxies have them. M87 is really huge. It's 120,000 light years in diameter. It has twice as many stars as Andromeda, 2 trillion, and it's about 9 magnitude. It has 15,000 globular clusters. I imagine some of those little specks in the image are the globular clusters surrounding it. Now, this came through my Twitter feed, and it was just, I got to show this. This little speck is the Milky Way. There's Andromeda, that's M87, which is a huge galaxy. And then this IC 1011 is the largest galaxy in the known universe. It's 350 million light years away, 6 million light years in diameter, 100 trillion stars, and it's in Virgo also, but beyond the reach probably of my scope of 14.7. Oh my God, that's huge. And there is Vince's quasar. It's right in this same area. I probably saw it in my eyepiece, but I didn't know what field of view to look for. And that's why I'm craving getting on Sky Safari to be able to know the view that I should see in my eyepiece to find it. That's what it would look like. It's 2.4 billion light years away, and something that if you want to try for, it's out there. And this was going to be before the break, in my mention of getting badges. Most people pick theirs up. If you're a new member and you need a badge yet, come sign up. If you're a paid new member, and that's the end of my piece. So if any of you in the future want to do this, just let me know during the month. And your 5 minutes of here's the thing that's been frustrating me, here's how I fixed it, or here's my new piece of equipment, or anything I learned, so throw it in.
Okay, so I have one item, a picture.
Okay.
Yes, because it's a great segue, or Doug's was a great segue. So here it is. So the one clear day that we had this month, 7th of April, I managed to get this image through my scope and my imager of Quasar 3C 273. So there you go, Doug.
It does look quasi-stellar.
Yes. So it's just amazing that that light you're seeing there is just 2.4 billion years in transit. So, all right.
Yeah, I've got one thing. One thing I wanted to bring up, just another little astronomy thing, is some people that have telescopes that have GPS associated with them may not have, depending on how recent your telescope is or mount, may have experienced a GPS rollover event that happened at the beginning of the month. And what some astronomers are experiencing on their telescopes is that the date goes back to like 1999. So it doesn't actually affect your actual GPS coordinates or anything, but if you have the wrong time, it's saying you're back in the 1990s. It's 1999 again. So
we'll party like this.
Well, I wanted to let for Celestron owners, I only know about Celestron. I happen to be on a software beta test team Celestron. This morning they released the beta test for us to test out of the software for the old hand controllers on the older, they call them version 4s, the Nexstar hand controllers, the Nexstar Plus hand controllers, and the StarSense hand controllers. So they're going to fix the firmware issue or fix the issue with the GPS through the firmware on the hand controller. So hopefully when I can get home, I can go and get the firmware updated on those different hand controllers. I can test it out, and in the next couple of weeks, Celestron will have that public release so that everybody can have that GPS issue resolved. So,
do you want to go right in and discuss outreach?
We can go right in and discuss outreach. We just did an Earth Day on Saturday. The Garden of the Gods said that their count was somewhere in the 3,600 number. I didn't count that we reached quite that many people, but I did go on a nice 2.8 mile hike. I set up a solar system walk through the park, so as people are walking through the park, they go by Mercury and Venus and the Earth, and there was a scale model of the solar system to a 30-inch Earth. And I did some lessons learned. Not everything was perfect about it. But when I went back on my second 2.8-mile hike to go pick up each of the posters that I put down along the way, it's 2 miles, 30-inch sun, by the way. Pluto's 2 miles away. But on my way around, there were people stopped at the signs and reading about each of the planets, and I ended up talking to some folks at each of the places. So that went really well. And then we had Ralph and Dave Nasser were there. Bruce came out. We had some solar telescopes set up to look at the skies. And in addition, I had my 10-inch Dobsonian out there. I just had it set up, regular telescope. And we were showing people how telescopes work. And I was pointing at, there was a big excavator that was tearing down the visitor center on top of Pikes Peak. And I talked to some folks about the observatory, maybe getting built up there soon, so a good target of opportunity. And I showed people climbing up on the rocks and people walking, and I guess this is like Red Rock Canyon Open, the Red Rock Open Space. We could see people walking on the trails in Red Rock Open Space from Garden of the Gods. So, and the Kissing Camels and Friends of Garden of the Gods board member wanted to come and see if they could see the prairie falcons, and it ended up being a lot of networking because we have fluorescent fossil beds was there. They said that we're the greatest thing since sliced bread, that we bring more people to see the skies than to see the fossils. And we're like, we're looking at fossils too, as a matter of fact, but they really appreciate it, which leads us that we do have a fluorescent fossil beds event coming up. 1 week from Friday, we'll be up there Friday, May 3rd. I know it's on top of the imaging event and our club member event, but if you can make it up with and join us at fluorescent fossil beds, love to see you up there. Nice dark skies there to come and see those enjoyable sights. But we had a good time at going back on Earth Day. We had a good time out there seeing all the people. I talked to a bunch of different Girl Scout troop leaders that want their young ladies to learn about astronomy and that sort of thing. We said, well, we got some great events coming up. Here's what we've got. One of the other events that we have just coming up this week, hopefully the weather is good, is we have our last of our 3 astronomy lab events that we do every spring and every fall. We do 3 of each. This one's at Pikes Peak Community College downtown studio in the central campus. The way you get there is you go west down Bijou Street until you get to Sierra Madre. You turn left there right before you get to the bridge, and there's a little strip of park right there on the left-hand side. Park next to the park there, and your telescope set up, and boom, we're out there and observing. It's actually surprisingly nice little dark spot in the middle of downtown Colorado Springs to go show the celestial sights to anybody that happens to stop by. It is open to the public. We usually have mostly the students. Anybody that waited to the last minute to finish their astronomy labs, that's when we'll see them. So we might have a few. But it's also, we're watching the weather, not quite sure how that's going to turn out. We'll keep an eye on that, but partly cloudy right now, so we might get some chances to see some stuff. I think that somebody else is going to talk about the Observing Astro Imaging event. I talked about fluorescent fossil beds. In addition to coming out for Starry Meadows Work Day that they're going to talk about in a minute, we also have the May the 4th Be With You club member event. So come out, help with the work day, get ready for RMSS, but then stay for the stars and go enjoy the night skies that are out there at our Starry Meadows property, and it's be awesome. I wish I could go. I'm actually having an event that I didn't put on the calendar. I'm actually going to be doing an event out at Simla, Colorado Library. Simla, if you don't know where that is just beyond Rama State Wildlife Area. Got the town of Rama. The next town down is Simla, and they contacted me and they said, hey, we'd like something. How about May the 4th? And I said, oh, May the 4th be with you. Well, I can come and talk about the force of the sun. So I'm going to set up solar telescopes, do some solar activities, probably the UV bracelets. The little kids always love that stuff. So I'm going to take care of that and enjoy. And hopefully, we'll have clear skies down here too. Next, if you can go to the next month, just have a couple real quick things, and we're all done. Pretty light. Now I do have some other events that are in the planning stages, but I'm going to be at Horizon Middle School on the 9th of May, just for one of their last of the school year's star parties. We had a really bad last couple of months with clouds and lots of cancellations. Good for getting moisture into our rivers and our reservoirs, but we do have one big event before I'm done here, and that's we have International Astronomy Day coming up again. It's spring. We have Spring International Astronomy Day. That's going to be at Garden of the Gods. I'm currently working with Elizabeth Barber out there to work out what our plans are, but I'm going to need some help in terms of we'll set up solar telescopes in the daytime, do some activities with the folks. I think we're going to have maybe 3 to 5 talks during the day, just short talks that we're going to give at the Garden of the Gods in their Red Rocks Theater during the daytime because they want to do some talks. And then in the evening, after it gets dark, about 8 o'clock to 10 o'clock, we're going to do our night sky program. We'll also have supporting us there the NSSTI guys with their mobile Earth Science Observatory is going to be set up there for both the daytime and the evening. So we'll have their big mobile telescope setup, which would be a big draw. Come and see them. So that's what we've got coming up in outreach for the next month. I hope you can come out to one of those events. If you can help me out with International Astronomy Day, come with the telescope, especially in the evening for that nighttime observing. We're probably going to have somewhere around 600 people, maybe more, if it's a nice, clear, warm spring, summer night. We could really use your support with showing people the night sky with your telescope. So, great, yeah. Thank you. Thank you.
All right, this is going to come up and talk about what's up in tonight's sky.
Okay. I'm really excited that we had 2 different members go after that quasar. That's cool. I'm with Doug. When I went and found it, I'm not sure I saw it the first time, and I had to break out uranometry and overlay the transparencies and make sure I was looking at the right thing. But knowing the story behind it, I think is what's cool. How's the portability of that XD12, by the way?
Suitcases about 50 pounds each. I've got a wheelbarrow and moving me on because I've got a bad back.
Yeah, but you're doing it, so.
And they'll go in the back of my SUV.
It's a lot of grasp too, so pretty cool. I think we have Doug to thank for a lot of the clouds, so next slide. So we'll start with the lunar information. The April full moon, as we said, was the pink moon, named after the flowers that start to sprout. We just passed that. May's new moon is May the 4th. I think maybe we could call this one the Arcturian new moon because Arcturus is, very close to meridian. And then the May full moon is on the 18th at around 3:11, and that's called the flower moon. Next slide. So we'll look east on the new moon. I cut out the start of the month and end of the month thing. We'll just look at the dark sky. So next slide here, and then we'll look at zenith at midnight on the same time. May 4th, looking over here, we can see some of the prominent constellations that are starting to rise. It's probably our last good month for galaxy. So I've got one more thing on there, but so let's go to the next slide. So here we are looking up north, south, is down as usual on May 4th at midnight. There you can see Arcturus. I've tried to use the scaling thing in Stellarium to make these stars maybe a little bit more visible for you, but there's a couple of good things here already. You can see M3 is well placed for viewing, so I've got something on that as well. But if you click it again, here we go, galaxy season one more time, and here's where that view, the really dense portion of the coma cluster is that Doug talked about. So if we go to the next slide, you have this M87, which is again now highlighted exactly where it is. If you go to the next slide here, they call it the smoking gun galaxy, which I think is so fitting for this black hole discussion that we've been having. But here's a visual picture of this galaxy, and you can actually kind of see this little jet that is emanating from it. That black hole, they've done these calculations now and say that there's like 6.5 billion solar masses in the hole itself. So this is one massive galaxy. I really like the infographic that Doug showed because it gives you the scale and size that we're looking at here. We really had no business seeing that black hole. There's just too much stuff in the way. It's kind of like the discussion on New Horizons where they had to go to the Hubble to see through all of the clutter in Sagittarius. This is hopeless, right? So the best we had until recently, this next slide, this wonderful thing of this jet coming out of what they call the accretion disk, and this is, you know, it's kind of a technical jargon, but basically the cyclotron motion of this stuff spiraling into its depth, and the black hole is heating up and shooting things out in a certain preferred direction. If you're mathematically inclined, it's the cross product, and this is coming out perpendicular. This was kind of the evidence. In fact, I kind of got a chuckle. I was looking up some stuff on this, and they were saying, and it's suspected to be a black hole causing this, but you know, there's no confirmation or anything. It's like, well, yeah, about that. Next slide. So of course, the picture that Doug showed. Just wanted to pause here and think about this. Like, ask a question. What do you think the oldest science? I would think that it was probably our science because there it is. But then after that, probably ours, right? Astronomy, right? I think that the first time anybody looks up and goes, "Wow, look at that! What is that?" You know, this is the kind of thing that they're curious about. But it's also kind of one of the newest sciences. You know, I've got a buddy who kind of got me into this hobby in a real way. He's forgotten more about astronomy than I'll ever know. Dave used to be a member of this club until he moved out, and I met him through work. But he didn't do a lot of stargazing for a while, and I said, "What's going on? Why don't you do this anymore?" He goes, "I've kind of seen it all. There's nothing new here and everything." And now he's really excited again, right? Because it ebbs and it flows or something. So it's true. It's probably the oldest thing, but it's also one of the newest things. This image didn't exist until just recently. Like I said, we had no business doing this. These are radio waves. So we found a clever way to get through all of that clutter, which I think is just fantastic. To find out that the center of the black hole is 6.5 billion solar masses. But that's just one of like a couple that we've seen that really profound discoveries recently, right? There's these gravitational waves that the advanced LIGO solve, right? That's cutting edge. That's confirmation of existing theories, as this was as well. But I think it was this year or last year, they've also discovered galaxies that don't have any dark matter. Like gravitational speeds are all making perfect sense. And now there are two of those, right? And that's going to modify it, right? And then they're constantly finding these higher redshift structures that shouldn't have had time to form. So that's going to rewrite things. Like, in a way, this is the newest science, even though it's also one of the oldest science. And I find that fascinating. That's why I love this hobby, right? I mean, you watch the collider get built, and it took 20 years for CERN to go, and finally they achieve, you know, confirm the Higgs. That's cool, but it took 20 years, and this is just happening year after year in astronomy, and I think it's a golden age for us because the detectors are getting so much more sensitive, and just the techniques are getting so cool. So anyway, that's kind of it for the galaxy season. At least I won't maybe highlight so much on galaxies, but this is my favorite time of year. So next slide. So there are other things up there. Like I said, there's M3. M3 is about in its best position, at least for this new moon and 4th of May around midnight. So next slide here. M3 is this gorgeous globular cluster, right? So these globular clusters are kind of strange things. They're not like open clusters that kind of form, but they're sparse and they're within our galaxy and they spread out eventually. They're almost like miniature galaxies, right? They form and they tend to be fairly metal poor. They're ancient old stars, and they form very tight clusters like this in bizarre places in a halo around the galaxy. And there's implications for all of this, and we've learned a lot from these globular clusters. This is what Hubble was actually studying in Andromeda when he set the Hubble constant that, you know, literally just, you know, made the universe that much bigger, right? He was looking at heavy variables in globular clusters in the other galaxies. So very nice object. You'll be able to see this even from suburban skies with relatively good sized telescope, even say 4-inch, you can see these binoculars in dark skies very nice on thing. It does. Actually, they're almost prettier through art class telescope. Can't resolve the stars, but they sort of pop into relief every once in a while. They look like glittering snowballs to me. So there are a couple of neat variables well placed. Some isn't the data whenever this was supposed to be a animation, but behind this is Corona Borealis, and can you kind of go back? There we go. So here's Corona Borealis, and if you saw, it was starting to rise at twilight, and then this thing is going to be pretty well placed, not quite due south, on the new moon night, and kind of right in the center here is this fairly prominent star, and that's this R, Corona Borealis, and it's a variable recurrent nova. This is a strange star. So we'll go to the next slide again now. So this one, it's funny, 1999 came up twice. Good year. Nothing wrong with having to graduate high school in 99. So going all the way back to, it depends where you are, but party like it's 1999, I'm with you. So this is the light curve for that star, and most of the time it hangs out here right around the edge of visible, right? It's not that hard of a star to go out. But every once in a while it fades to where even our big scopes are going to have a hard time seeing it, right? So right now it's kind of back to normal, but an interesting star, and it's just a freaky weird star too, the way that it swings through these things in no regular motion. The physics isn't all that well understood about this thing. Kind of an interesting thing. It's going to be another one of those that if you do track this down, it's going to look like something. And then hopefully come back to it when it starts to do one of these weird dim things. There's another one near to it that's even crazier. Delta Blaze star. This one's going to be a lot harder to find. But this thing is like reverse nova. It's a lot brighter, right? So 10th magnitude next. So here's its light curves going back. This was like 2012 to present. And you can see that occasionally it's jumping as bright as almost naked eye visible to like 7 and some change. In fairly recurrent periods. And the reason for this one is a little bit more understood. It's assumed to be a binary star, and there's something going between the interaction of these two different stars. Still kind of a neat thing that we can track down right now. Also, if you're interested in this kind of stuff, I've grabbed this data from the AAVSO, the American
Association of Variable Star Observers.
Right? So they'll let you go in and grab these light curves from folks like us who report these. They'll give you training on how to estimate these if you're interested in contributing to that. A wealth of good data there. But then on top of that, there's the Center for Backyard Astronomy, or Variable Star Astronomy,
Astrophysics,
which is really nice because it's almost our website, CSASTRO, it'll see the answer. So you can go to that one, and then there's a mailing list, and you can get put on alerts for when some of these, there's lots of these variable stars, but when any of them start doing something interesting and they want really quality data, you'll get a blast and say, hey, go check this one out. So, cool. Next slide. So meteor shower, a lot in the news for some reason about the Lyrids. Like I said last month, it's not a very good one to see. Lunar phase isn't as support. It's ongoing right now. I think that its official peak was yesterday, but I don't know if I would bother even going out for that. But there are 2 different showers coming up here in May. There's the Lyrids that peak on the 8th of May. You only get 4 to 6 per hour. It's not a very rich shower. The Eta Aquarius, they're a little bit more rich, 10 to 80 depending. Some sources I see put it more like 20. So these aren't like the Leonids or something where you're going to see a lot of them. But 2 of them together, the nice broad peak on the Lyrids might get both of those combined. Early in the 6th might be a decent time to go out and look for meteors. Next slide. So there's the radiant again, with the moon phase being horrible for the Lyrids. The next slide here. This is where the Lyrids were. It didn't show up very well, but kind of close to Jupiter and the southeast. And then this is around midnight, so it's not high by then. The one that was a richer shower, next slide, is not going as far as the radiance is concerned until like 3 in the morning. But by then, here's Jupiter again, and that radiant other one was. So they're both fairly well placed, and of course, the radiant doesn't have to be above horizon for you to see, some of the showers. So, but that's about it for the meteor showers. So looking at all the Messiers, lots of good Messier objects to look at. So any one of these, if you're new and you want to Google these and figure out how to look for them, most of these are going to be good objects to go after in a 6-inch telescope. Depending on which one it is, you won't even need that big of an aperture. Or if it's some of these galaxies, you probably want a larger aperture and darker skies. Depends on what you're going after. Classic objects to go after, though. Really not a good one for comets. And then the planets haven't changed at all since last month. If there are planets, they're generally in their early morning. Like I said, Jupiter was fairly well placed just after midnight. The rest of them are rising, and Mars is setting. The views are getting a little bit more lucky, but I was able to see it the other night, and it looks pretty good. Next slide. So that lineup that I showed last time, which was technically yesterday, is still actually pretty good for the next couple of days. You have this really nice layout of all of these planets at once if you get up just before dawn: Mercury, Venus, Saturn, Jupiter. And I believe that was it. Yep. Thanks, guys.
Thank you very much. All right, we're going to move on to our committee. People, when you're going to be talking, please bear in mind we have 20 minutes until we have to be out the door. So keep your comments as brief as possible and direct as possible. Appreciate it. First up, Scott, are you ready for the treasurer report?
I'm ready. Okay, so this is the report for the first quarter of 2019. Basically, we are either on or under budget. 3 months, in the first 3 months of 2019, we had a net total gain of just over $5,000 to our accounts. During the time, we received about $400 in donations. Property taxes have been paid to Huerfano County, and that is it. If any member would like to have more detail, I can provide that to you. Just see me after the meeting.
Okay, great. Bruce, do you have anything for the long-term planning?
Long-term planning met this month. We made some good network connections. Scott and I happened to be at the Space Symposium, connected up with some folks with the city of Colorado Springs. So we're still in that getting networking out there, connecting through, getting the right people to support our effort. For those people who don't know what I'm talking about, the effort is the 24-inch telescope that was given to us by the Air Force Academy. This is a very historical telescope. More details, you can check over there or chat with me afterwards.
Astrophotography
group. There are two real interesting events that are taking place this month. Is next Tuesday. We have our normal or a little bit more advanced astro imaging group. And the topics that I think probably one of the better ones we've had in terms of the concept. It's all about sensors, the camera sensors. A lot of information that not only is actually very seldom talked about and used, but not details for detail's sake, but actually details for the sake of how do you then use whatever lenses you have and camera settings to actually make the images you're producing better. It's easy, very easy if you use the wrong settings and the wrong adjustments for the lenses, is what image you have and lose 20, 30, 50, 80% of the capability or the data that's collected. So it should be a really interesting presentation. NASA is coming 1 week from tonight. The novice imaging group, which is normally held on Tuesday, which is the 2nd of May. Thursday. Tuesday. Yeah. I'm reading it to the math on is Tuesday and Thursday. Normally it's at Bear's house, but because we're having a very event down at our property, at our RMSS site, Starry Meadows, We're gonna have whatever groups we have that can come down, we will be at Barry's house, but we will be meeting down the Starry Meadow. Some of us will be down there starting the 2nd and leave Sunday the 5th. But if you're interested, come down even if it's just one night. That would be fantastic. We'll actually design to help people that are starting whatever equipment they have to be able to actually go kind of one-on-one and help you get used to using it, or use somebody else or what they like to share. So that should be a really fun time as well. Even if you don't have a camera coming down. And during the day, we're going to also be trying to help out, and not just working on the telescope we have, but also getting the ground ready for RMSF.
Great, thank you, Brian. Tom, you want to come up and talk about your mountain star steer?
You bet. Very quickly, we have some new people here. You may not be familiar with Rocky Mountain Stars. It's our annual star party that we put on our own 35-acre private property that we own near Garden, Colorado. It's June the 26th to the 30th, and all of our planning at this point is on schedule. We're where we need to be. Wednesday through Saturday, and people pack up and leave on Sunday. Our registrations right now, we're up to about 150, a little 140, 147 people so far signed up. We expect to exceed 300 like we did last year. Do not put off registering too long. You've got about two and a half more weeks, and then the price will jump up by a factor by 50%. And we do that for a couple of reasons, but needless to say, we have to do that for planning purposes. We want people to register so that we have a good head count, a decent idea of the head count, and also merchandise ordering and things like that. Any questions? Thanks, Ed. By the way, I've got a lot of volunteers helping out. I just want to, again, thank all the volunteers that are helping out this time. There's a big work weekend coming up to get the site ready, and I think that Barry will be talking. Barry, you're going to talk about that. I'll let Barry talk about that. That's, I think, all I have for now. Thank you.
Right there. Come on up. I'd like to start talking about the workday, and it's going to be May the 4th down at Starry Meadows, and we're going to be providing lunch. And I wondered if there's 3 things we're going to do. We're going to mitigate fire, so we're going to be cutting branches and shredding them up and stuff like that, spreading it out. And we're going to be, there'll be some work going on the observatory. By the way, Tom and I went down, we got mechanically working with the motors and everything, so making some progress. We're also working on the wedge and trying to get things prepared. Brian's working on the electronic side of it. So things are going really well with that. The other thing, we have to work on the building. We have a few things to do to the building. Depends on how far we get on the electrical project. Now, I'm scheduled for the first of the week to have electrician come in, but it's all going to depend on when we get our inspections and things to when we can backfill the ditch. We're going to backfill the ditch. We're going to use a four-wheel drive with a blade and get it backfilled and tamped and drive over it and what we need to do to get it tamped down. So we're making some really good progress. Just for food-wise, we're going to provide lunch for you. Can I see a show of hands of who might be able to come? Okay, good. That helps me a lot. I just want to make sure I've got enough food. Okay, and I just want to tell you we're now the proud owners of. You want to show me show my?
Oh yes.
Over there.
Okay, stand by.
Yeah, you can.
Yeah, wait till I'm ready.
Okay. Proud owners of a ditch. Go to the next one. Everything went well, and you can see it's pretty long, 100 feet long. Came in right on budget, about $700. And the guy that did it is just really a master at digging. And you can see we got a little bit of dirt to push in. It's not overwhelming. I did want to share that if you're going to come down, you want to work with the tree clearing and chipping and all that, please bring safety glasses and wear good shoes and gloves. So come prepared. You want ear protection, eye protection, hand protection,
good pants, you know, that kind of stuff. Just come ready for that. And outside of that, that's all that I have, and I sure appreciate the show support.
And lots, yes. Long sleeve shirts, you'll get war wounds on your hands. And definitely ear protection. The Vermeer, it's a commercial grade wood chipper, is extremely loud.
What?
So, make sure you bring ear protection. I will bring extra foam inserts just in case, but please bring some headphones or something.
Just an aside, Matt told Bruce that he could not wear his kilt, so he won't be joining.
Celtic suppression. Celtic suppression.
Right. Does anybody have anything else?
A reminder, part of our outreach program is on KRCC every Monday at 9 a.m. and 9 p.m. Looking up segments put on by Al Bidlack, and on occasion I do one.
They're mentioning this on Facebook now, so like their page and you get those reminders of all the different ones that they've got. You can watch, you can listen to them on podcasts or however you listen. They're out there in archive for you to listen.
And I challenge people to figure out the underlying theme of all of mine.
Tom, did you want to mention that magazine or whatever that was? That
It's the web. In fact, I downloaded it. Yeah, we got contacted yesterday by a website, a travel website called Culture Trip, and they're pretty big as it turns out. I was looking them up, and they got a nice app. And if you do much traveling to other cities and other countries, a lot of information on that website. Called, I think it's culturetrip.com. Anyways, what it's worth, they want to do a special on star parties, and they want to use RSS as their example, I guess. So they reached out to us and were sending some photos and some imagery of RMSS. And so we're going to get some promotional, I would say, benefits out of this as a result. Thanks for doing that. I'm sorry. Yeah.
All right, great.
How many are familiar with a device called an atmospheric dispersion corrector? For those that are either interested in observing or imaging, this device can correct for the dispersion of the light waves, the different colors and so forth, as you get lower and lower in elevation. Now, I just found out yesterday, it's probably been out for a few months, but ZWO is a company that makes a lot of wonderful astro imaging equipment, such as cameras and so forth. And they have a device with two prisms for about $128, which is dirt cheap, where this guy did a review on it, and he said, it's a little finicky to get them adjusted, but the nice thing is you don't have to be perfect. He said he could get the thing set up in less than 15 minutes, and it fits right in the back of the scope between your, let's say, your full reducer and your camera. And that is cheap because in the past they were significantly higher, probably 4 or 5 times higher. $128 ZWO. All the top retailers have for this price right now.
One last thing, for those of you who don't know, we have a pre-meeting social, which is over at Trinity Brewing. Bruce tends to get there at around 1 o'clock in the afternoon, I think.
I work 2 blocks away. It's within staggering distance. I'm walking.
So what time do people typically show up? 5 o'clock. And then we also have an after the meeting at the Village Inn for just social time, which is right down by the highway here on Garden Road. So other than that, Scott?
If anybody has any business for the treasurer, paying membership dues, please see me after the meeting. That's it.
That's all I have. Meeting's adjourned. Actually, you guys can all
Okay.
get this room back into configuration. Most of these blue chairs will be stacked up against this wall over here.
Just CSASTRO.
Is it hang on 2019 or?
No, it's like basically whatever month you.
Why are we having to sale, property tax in Hortonville County? Do they not exempt 501c3? We are a C3.
No.
I went online and take a look and see.
If you look into that, would you send me an email to?
I tried, didn't hear anything about it. Yeah, I'll get it to you.
I don't know if you should check
how much are they?
It's like $1,600.
I'll try to take a look.
Yeah, so I assume it's the treasurer doing it this year. Like right now, I'm doing a tax review.
You would mind checking
And property taxes came out, that was in January, so it's like new treasurer, new property taxes.
Sure. I'll try to figure it out, but I can't even remember state law just says they can't charge. And if they do.